Well, this is the circuit of inverting amplifier using operational amplifier. So this is amplifier with a very high open loop gain AOL. It has positive and the negative supply pins. And then by utilizing the feedback through the resistor R2 and C1, and applying the input signal to the negative pin of this amplifier, we are creating inverting configuration of the circuit. So you have the signal right here and you will have an amplified version of it right here. And the output expression is the ratio of resistors with the negative sign multiplied by the VI. So VO will be equal to gain times VID, which is the gain times the difference between the two inputs. So we have seen this analysis where V1 and V2 are the voltages at the negative and the positive pin of the amplifier. Now R3 is chosen just to cancel the input bias current. So accordingly, we can choose that. Values of R2 and R1 are chosen to be about 10 mega ohms. So they're pretty high. Value of R3 is 5 mega and C1 is 3 picofarad. Now why we are calling it amplifier with high input impedance? So with the negative feedback amplifier, you have an input impedance, which is the impedance that you look inside the op-amp from the input side. So that is R in, which is basically the VI divided by V in divided by I in, and V in is your externally applied signal and R in is the current that is going to flow into the circuit. So R in is basically equal to R1 if we do the analysis and see the circuit, because you see this potential voltage right here with the R3 very high, negligible current flows through it, and this V1 is at the zero, and through the virtual short concept this zero voltage comes at the V2 also. Therefore the I in value will be V1 divided by R1, or R1 will be V in divided by I in. So R in is actually R1 for the inverting configuration, and the value of R1 is 10 mega ohm. That's why we call it as an inverting amplifier with a very high input impedance. Okay, so the advantage and the gain also, you can see the gain is both resistors are equal value, therefore the gain is set to be 1. Okay, there is one more concept here which will be called as cutoff frequency or the pole frequency, which is 1 over 2 pi R times C, where R will be R2, C will be C1 in the feedback configuration, feedback path. You have this network. So that will form the first or dominant pole of the gain. Okay. So you have this gain right here, and then you will have the frequency response, something like this, where bandwidth of the amplifier, usable bandwidth of the amplifier will be from 0 or DC to certain frequency. Okay, and then this is called as unity gain frequency, unity gain bandwidth. Okay, so where your gain is actually unity or equal to 1, and the frequency at which this happens is called as UGB. Okay, this is your minus 3 dB point, minus 3 dB frequency, where you actually get this cutoff frequency or the pole frequency. So that is decided by the values of R2 and C1.